Okay, next part here. Determine the domain of a logarithmic function. Alright, so we can kind of use what we know about exponential functions and inverse functions to kind of reason this out here. We said that the logarithmic function was the inverse of the exponential function, right? And so since those are inverses, that means the domain and the range switch places. Remember we said that? So that means the domain of our logarithmic function is going to be the same as the range of our exponential function, which, if you'll remember, it's from 0 to infinity. Right, the kind of the standard range of our exponential function. This thing typically looks like this, right? And so the range here, the y values that we're covering, goes from 0 to infinity. You know, think of that as your lower boundary and your upper boundary on your y values there. And so what that tells us is that when we're dealing with logarithmic functions, the only numbers that work for the domain are values that make this piece right here positive. This has to be greater than or equal, or I'm sorry, greater than 0, okay? Because in order to plug a number in there, we can't take log base 2 of a negative value, okay? Because that kind of violates what we've got up here about the domain being the same as the range of the exponential function, just those positive values. So what we're saying here, to find the domain, really all you need to do is take whatever is inside this logarithm function, this x plus 3, and say that it needs to be greater than 0. It needs to be positive, greater than 0. So if we solve that, we get that x is greater than negative 3. And so that's the domain of our logarithmic function. We can write that a few ways. We could say x such that x is greater than negative 3. We could also say that's the interval from negative 3 to infinity. Okay, so both of those are good answers for that domain. Just make sure you pay attention in the homework and know if they're asking for interval notation or the set notation. Okay, just be aware of that. So that's all you got to do is take whatever's inside that logarithm notation and put a greater than 0 and solve that. Alright, so let's take a look at the graphs of these logarithmic functions. And so if we want to get the graph of a logarithmic function, again, we can use the idea of inverses, right? So it says, for example, to graph log base 2 of x, we could graph 2 to the x and do a reflection. And so similar to what we did when we talked about those inverse functions, we can reflect y equals 2 to the x over that line y equal x. And so I'm just going to plot some points for y equals 2 to the x. If you'll recall, that's that exponential function. Looks something like this. Right, where those order pairs are 0, 1, 1, 2, again, 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, and so on, right? So there's those points that I got. Now we can reflect those over this line y equal x. And if you remember to do that, you just reverse the coordinates, right? Since these are inverse functions, x and y just swap places. So we get these coordinates. So what does that look like? 1, 0. 2, 1. 4, 2. 8, 3. And then kind of continuing the pattern, we'd have, you know, these points that get closer and closer. So we end up with this graph right here. Okay, so this is y equals 2 to the x. This is y equals log base 2 of x. Okay, and so you notice the way that logarithmic function looks kind of has some similarities to the exponential function, where it's kind of got a vertical asymptote here at the y-axis, and curves around there. No negative x values here. Again, that goes back to what we just said about the domain. X values must be positive, right? So that's what the graph looks like. And as you can imagine, the base of that logarithm is going to affect very much the base of, the shape of the graph, just like the base of the exponential function affects the shape of the graph, right? So same idea there. If you change the base, it's going to really affect what happens to your graph. So as another example, graph y equals log base 1/3 of x. And I'm actually going to do this on the calculator. Well, we can't quite do that just yet, now that I think about it. And I'll tell you why we can't do that just yet. If you look at your calculator, you've got this button, that's a logarithm, and you've got this button, that's a logarithm. Now, the question you might be asking yourself, if you're thinking the right direction, is, okay, I've got two logarithm buttons. How do you do the base, like if I wanted to do log base 1/3? Well, the problem is that the bases for those two logarithm buttons are set. We already said ln has a base of e, that exponential value. So that's set. This log button right here, it's actually a base 10 logarithm. That's what it's set as, and you can't actually change the base of that logarithm button on your calculator. So we'll talk more about that in just a minute, but that's why I'm not going to jump straight to the calculator right away. But if we want to graph log base 1/3 of x, we're going to start with the inverse function, y equals 1/3 to the x. Okay, so 1/3 to the x. Think about what that's going to look like. It's going to have that 0.01. 1/3 to the first power is 1/3. 1/3 squared is 1/9. So you can imagine this thing flattens out. If I do a -1, 1/3 to the -1, I get a +3. And then a -2, I get a +9. You can check these on your calculator. You know what's 1/3 to the -1 power, and so on. Okay. All right. So I get those points. So I get this graph. Now if I want to reflect that again over the line y equals x, then I just switch the coordinates. So I get 1, 0, 1/3, 1, 1/9, 2, 3, 3, -1, and 9, -2. Okay, so 1, 0, 1/3, 1, 1/9, 2, and then 3, -1, and 9, -2. So I get a shape like this. It's kind of different than what I just had, but still a reflection over the line y equals x. You'll notice it still flattens out there. We don't have any negative x values over here, and so really interesting. Changing that base, like I said, it does affect the shape of your graph a lot, a whole lot. All right, so here's some properties of logarithmic functions. For what we're doing, I wouldn't worry about those too much, so feel free to look over those, but I don't think there'll be anything like this in the homework, so don't worry about it too much. Now let's go back and talk about the calculator a little bit again. There's two common logarithms, or two bases of logarithms that are really common to a lot of problems and that we use a lot. One of them is the natural logarithm that we already mentioned, ln. And I kind of went over this earlier, but if we say y equals ln x, y equals the natural logarithm of x, means the base of our exponent, the base of the logarithm is e, that exponential value. Okay, and that is exactly what that ln button on your calculator is. It's a natural logarithm. We also have what's called a common logarithm. Okay, if we take this logarithm and drop the base, we don't put a value there, it just says log x. That's an understood base of 10. So if you see log x, it's the same as log base 10 of x. Okay, and so that's only true if x equals 10 to the y. And that is this other button on your calculator, this log button. Okay, it's a base 10 logarithm. And so we can use those, if we want to evaluate a base 10 logarithm or a natural logarithm, we can do that.